Dear students, today we are going to discuss here the last unit from section 1, this transition and inner transition elements, that is unit number 8 from your section first. विद्यार्थी मित्रांनो, आज आपण त्या ठिकाणी सेक्शन फर्स्ट मधलं जे लास्ट युनिट आहे ट्रान्झिशन अँड इनर ट्रान्झिशन एलिमेंट्स, याच्यामध्ये आपण त्याचे इंट्रोडक्शन असेल, पोझिशन असेल, simply electronic configuration, properties of particularly transition and inner transition elements, that are D and F block elements, their uses, etc. So details are seen in given units. So today in this lecture we are here going to discuss 2 to 3 points. First one, introduction for this unit. Second, position in the periodic table, and third one, electronic configuration. And in next lecture we see the remaining part of the electronic configuration, that is electronic configuration of chromium and copper and oxidation state of first transition series. यामध्ये हा पहिला पार्ट जो असेल त्या पहिल्या पार्टमध्ये आपण त्या ठिकाणी त्याचे इंट्रोडक्शन असेल, पोझिशन असेल त्याची, आणि इलेक्ट्रॉनिक कॉन्फिगरेशन, दॅट इज जनरल इलेक्ट्रॉनिक कॉन्फिगरेशन फॉर ट्रान्झिशन एलिमेंट्स. अँड नेक्स्ट पार्ट नेक्स्ट लेक्चर जे असेल त्याच्यामध्ये इलेक्ट्रॉनिक कॉन्फिगरेशनचा जो रिमेनिंग पार्ट आहे, इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ क्रोमियम अँड कॉपर अँड सिम्पली ऑक्सिडेशन states of first transition series and some tables. So dear students, see first one, introduction for this. As in 11th standard we study the details of periodic table. So just structure of the periodic table, modern periodic table unit. So in given structure of the periodic table there are 4 blocks, simply S block, P block, D block and F block. So the middle one, that is S block, first 2 columns, that is there are total 18 vertical columns present in given periodic table. So first 2 columns comprises S block. Then next one from 13 to 18 it comprises P block, and in between these 2 blocks there is a presence of D block, that is from group 3 to 12. And below the main structure of the periodic table there are 2 rows, as we seen, that is lanthanide and actinide series, which comprises or which constitute the F block elements. So these 2 blocks or elements present in these 2 blocks are particularly termed as transition and inner transition elements, that is elements from D block are termed as transition elements, and the elements which are present in F block are termed as inner transition elements. So first we see the transition elements belong to the D block of the periodic table. As per IUPAC, the transition metal atom has an incomplete D subshell or it gives cations with incomplete D subshell. आपण जर पाहिलं तर त्या ठिकाणी याच्यामध्ये हे जे एलिमेंट्स आहेत ते period number 3, 4, 5 and 6, that is period number 4, 5, 6 and 7 या पिरियडची त्या ठिकाणी लाईन असेल, ग्रुप नंबर 3 to 12, that is starting from scandium and with zinc. Second 5, period number 5 starting from yttrium to cadmium. Period number 6, that is from lanthanum to mercury, that is Hg with atomic number 18, and period number 7, that is actinum with 89 number and with cerium. that is Cn. So these constitute d block elements or transition elements. So if we observe the electronic configuration for this one, that is for scandium, this is the last electronic configuration or outer shell electronic configuration is 4s2 3d1, and as we move towards from scandium to zinc, it goes on, that is 4s2 3d2 4s2 3d3 up to 4s2 3d10. That is, this transition metal atom has incomplete d subshell, or it gives cations with incomplete d subshell. How it gives cations? The cations are positively charged ions. So if you consider the example of scandium, its outer shell electronic configuration is 4s2 3d1, and if there is loss of one electron, then scandium acquire positive charge, so it gets converted into cation. So particularly the property of these transition elements are they have incomplete d subshell or gives cations with incomplete d subshells. So they also exhibit the properties in between s and p block elements. As we seen in these transition elements in given periodic table appears from group number 3 to group number 12. As the general electronic configuration or their orbitals are filled as n minus 1 d orbital is comprised of successively filled in each element, where n is the valence shell number or valence shell. As 3d series, in if you observe the period number 4 5 6 7, that is number 4, it is 3d series. That is 3d series means n is equal to 3, the last electrons enter into third series, that is 3d. So 3d series consists of starting with scandium, that is with atomic number 21, and ends with zinc 30. 4d series yttrium to cadmium, and as 5d it is lanthanum to mercury. It is lanthanum to mercury without those from cerium to lutetium, that is lanthanide series, as placed up below the main periodic table. And last one, actinium to curium without its actinide series, that is thorium to lawrencium. So if we observe the electronic configuration for all these elements, the general electronic configuration for these transition elements is n minus 1 d 1 to 10. The electrons enter into d orbital, that is from 1 to 10, and ns 1 to 2. So this is the general introduction for the transition elements. Now students, we move towards the next point of this transition and inner transition elements, that is position in the periodic table. As we seen in given periodic table, particularly they are placed in the periods number 4 to 7, that is 4, that is 3d series, in period 5 4d series, in period 6 5d series, and in period 7 the 6d series is placed. And groups that is group number 3 to 12, that is vertical columns, जे उभे कॉलम्स असतील ते नंबर 3 ते 12, आणि त्याच्यामध्ये ज्या सिरीज असतील त्या ठिकाणी सिरीज म्हणजे ज्याच्यामध्ये लास्ट इलेक्ट्रॉन एंटर करतो त्याच्या पहिल्या याच्यामध्ये जर पाहिलं 3d सिरीज आपल्या स्क्रीनवरती आहे. 3d सिरीज मध्ये त्याच्यामधला लास्ट इलेक्ट्रॉन 3d मध्ये जातो, त्याच्यानंतर 4d असेल 5d असेल 6d. तर हे सर्व त्या ठिकाणी या डी ब्लॉक एलिमेंट्समध्ये किंवा त्याच्या पोझिशन आहे. आणि पर्टिक्युलरली दे आर प्लेस्ड in between S and P block at the center. That is, the electropositivity, reactivity, and also property shows a gradual change from S block to P block through those of the D block elements. So simply it is the position in the given periodic table. So the next one, the electronic configuration. So the details about as electronic configuration in given in table 8.2, that is configuration of 3D series. पहिले जे त्या ठिकाणी पिरियड नंबर 4 असेल त्याच्यामध्ये जे स्कॅन्डियम पासून ते झिंकपर्यंत जे एलिमेंट्स असतील त्याचा जे ॲटॉमिक नंबर असेल किंवा एक्सपेक्टेड जे पाहिजे ते आणि ऑब्झर्वड ते इलेक्ट्रॉनिक कॉन्फिगरेशन त्या ठिकाणी दिलेलं आहे. सो स्टार्टिंग विथ 3D series. The 3D series begins with scandium, that is 21, and ends with zinc 30. So if we write in the form of noble gases, that is argon is the noble gas presiding to 3D series. 3D series नंतर त्या ठिकाणी लास्टला त्याच्या अगोदर आर्गॉन हा एलिमेंट्स त्या ठिकाणी प्रेझेंट आहे. इन द फॉर्म ऑफ आर्गॉन जर आर्गॉनचं त्या ठिकाणी atomic number 18, so its electronic configuration is 1s2 2s2 2p6 3s2 3p6. Calcium, the after 19, that is 19 potassium and calcium 20, so it belongs to S block of 4th period, has electronic configuration that is 1s2 2s2 2p6 3s2 3p6 and 4s2. Therefore the next electron, that is 21st electron in scandium, enters into the 3D orbital. So general or electronic configuration of scandium with atomic number 21 is 1s2 2s2 2p6 3s2 3p6 3d1 and 4s2. So here first feel the 4s level as we observe in the different rules and laws, that is above principle, Hund's rule, Pauli's exclusion principle, etc., or energy levels. How electrons into, that is lower energy level 4s will fill the first and then higher energy level 3d fills to the 4s. So it is short form electronic configuration as we see argon in bracket 3d1 4s2. So we observe the electronic configuration in given table. So see, with scandium 21, its electronic configuration expected and observed electronic configuration is same, that is argon 3d1 4s2, argon 3d1 4s2. Titanium 22 same, expected and observed electronic configuration is same for titanium. But in case of chromium, expected is argon 3d4 4s2 and observed is 3d5 4s1. This is the different electronic configuration. And also if we observe the electronic configuration for copper, it is 29, is expected is argon 3d9 4s2, but we observed the electronic configuration, it is seen as ar 3d10 4s1. So the details of this chromium and copper we see in next lecture. So first see the electronic configuration for this 3D series. Since zinc has completely filled the n-1 d orbital, that is n here n is 4 minus 1 3, there is 3d orbital in the ground state, that is the electronic configuration or valence electronic configuration is for zinc is 3d10 4s2. So in 3d 10 position its common oxidation state is +2, so it is not regarded as transition element. म्हणजे 3D series मध्ये त्या ठिकाणी स्कॅन्डियम पासून झिंक पर्यंत जे एलिमेंट आहे डी ब्लॉक मधले, तर त्याच्यामध्ये हा जो झिंक असतो त्याच्यामध्ये लास्ट इलेक्ट्रॉन असेल किंवा लास्ट ऑर्बिटचे जे त्या ठिकाणी इलेक्ट्रॉन कॉन्फिगरेशन असेल ते त्या ठिकाणी 3d10 4s2 म्हणजे ऑक्सिडेशन स्टेट काय आहे +2, म्हणून त्या ठिकाणी हा transition element that you can consider. So on the same ground or same reason, the cadmium and mercury, that is from column number 12, they are also not regarded as transition elements, that is from 4D series and 5D series. 4D cadmium from 4D series, mercury from 5D series. Now copper, that is 29. In the elementary state, it is 3D10 4s1. Observed electronic configuration is 3D10 4s1, contains completely filled 3 orbitals, that is 10, but in the +2 oxidation state it has partially filled a 3D orbital, 3D9 4s2. Hence copper is a transition element. So details in next lecture. So if you observe the electronic configuration for all these elements, we just see the electronic or general electronic configuration of 4 series of d block elements of periodic table. That is, first 3D series, that is from scandium to zinc, 4D series yttrium to cadmium, 5D series lanthanum to mercury, and last 6D series comprises actinium to curium. So first for 3D series, as seen on your screen, 3D series has AR 3D 1 to 10 4s2. Next one 4D series, that is krypton 36 noble gas, 4D 1 to 10 5s2. Next one 5D series, xenon 5D 1 to 10 6s2. And last one 6D series comprises or having generally electronic configuration is radon 6D 1 to 10 7s2. So students, this is the first lecture of transition elements. As we seen in introduction, general information of transition, anion transition, why they are termed as transition, because shows the variable oxidation state and different properties or variable properties. So they term as transition or inner transition elements. Next one, position, particularly they are placed in centrally of the center of the periodic table in between S and P block. And electronic configuration, that is details of 3D series, that is expected and observed. So in next lecture we see the details how chromium and copper shows different electronic configuration and oxidation state of these transition and transition elements. So thank you for joining this lecture.